Good afternoon. My name is Ljiljana Stojanovic. I'm head of Smart Factory System and Fraunhofer IOSB in Karlsruhe in Germany. And together with my colleague, Dr. Kim Watson and Friedrich Holz, I'm going to present our approach to combine complementary concept of Industry 4.0 with international data spaces. So as a use case, we selected our own marketplace for industrial production, the Smart Factory Web. The Smart Factory Web is an approved testbed of Industrial Internet Consortium. It is a platform that connects smart factories through manufacturing marketplace to enable flexible usage of assets, for example, in supply chain. So factory can register with Smart Factory Web by describing their capabilities, what are, for example, products they produce, or what are the processes they offer. And then the potential business partners, such other factories, can search for factories with the desired capabilities. The business partner can then place an order for the selected factory, and the key innovation is that the factory may have to adapt or to configure its production facilities to meet the order. For the Fraunhofer IOSB has the lead in this testbed. The other partners are Korean Electronic Technology Institute, KETI, and we have two industrial partners, Microsoft and SAP. In order to achieve the Smart Factory Web vision, there are many challenges we have to deal with. Data exchange between partners is a very challenging task. Especially since we have the production data for factories, and the customers want to see as much as possible information, but the factories do not want to share the data with unknown partners. And we have several very important questions. Can we connect the factories to the Smart Factory Web and exchange the data? And the second question is, how can we provide the information securely at the right granularity level, and how can we ensure that the data owner can choose how their data is used and is distributed? So we see two challenges. The first challenge is regarding the interoperability. We have interoperability at the shop floor level, and we have also interoperability problem in the marketplace level. To deal with these issues, we use already standards like Automation ML and OPC UA at the shop floor level, and we use semantic technologies, means ontologies, and at the marketplace level. In this way, we are able to resolve some syntactic interoperability problems. For example, we are able to exchange the data with standardized interface, or we are also able to resolve semantic interoperability problems, meaning the ability to assign the correct understanding to data. But what we want to achieve is that the factories are active entities, that they can offer different services to other factories, and that they also can collaborate with other factories. To achieve this, we have to go a step forward. We have to share the same understanding of the messages in a given context, and what we want to achieve is we want to be I4O conform. So our intention is to achieve Industry 4.0 conformity. The second issue that we would like to resolve is to ensure the secure communication and the control of usage of data. The Smart Factory Web is a platform where factory owners offer their production capabilities to customers worldwide. We are able to model supply chains in the Smart Factory Web, and the factory owner can control the usage of data by other business partners. For example, the factory owner can share information about the product with verified customer and restrict further sharing of data. We started to use IDSA connectors a year ago for the communication between the factories and the Smart Factory Web. But we also discovered the need to use IDS connectors for the communication among the factories during the negotiation phase and during the operational phase. For example, some additional information like prices, production plans should be shared, or also we would like to share real-time data, meaning status of the production with the partner in supply chain. So our intention is to use IDS components, to apply them and to integrate them into Smart Factory Web, and also to use as much as possible the usage controls and the trusted connectors. So in order to deal with these challenges, we set up several goals. Our first goal is extended interoperability. We want to integrate asset administration shell into Smart Factory Web. Currently, a year ago, we were able to integrate OPC-UI components into Smart Factory Web, and we have extended these OPC-UI components with asset administration shells in order to be Industry 4.0 conform. So the work has been based on I4AAS companion specification. This companion specification is extension on overall OPC-UA standard, and it defined information model that confirms the okay. So the work is based on the I4AAS companion specification. Our second goal is to extend the data sovereignty. It means that asset administration shell should be protected via IDS connectors. So the asset administration shell is the key concept in Industry 4.0. It enables to connect in a real asset with the digital world. And when company can share and exchange asset administration shell information among themselves, then the IDS can provide a secure and data sovereign platform in which the data owner decided the way the data can be used. And finally, our third goal is to create demonstrator to show the synergy potential between Platform Industry 4.0 and IDS. And for that, we have developed IDS connector with OPC connectivity, which enables to secure exchange the IS information between the partners. And this slide shows our architecture. As you can see, the architecture consists of three parts. The key part of our architecture is the OPC-UI factory connector, which you can see in the middle of the slide. In the upper part of the slide, you can see the Smart Factory Web, which is used to model supply chain. And on the right side of the slide, you can see different partners in the supply chain, which are connected using different IDS connectors. So the key part is OPC-UI factory connector. OPC-UI connector combines the benefits of IDS connector, which means secure and standardized communication and also the usage control, with the interoperability of Industry 4.0. It allows us to connect any asset administration shell and to ensure that asset administration shell can be published and secured over IDS. It is important to mention that OPC-UI factory connector is the gateway to IDS, and that it can connect any factory to any IDS participants, other customer, or the Smart Factory Web itself. And we also provide support to extend the existing OPC-UI servers to be IS conform. The owner of the factory can define the usage policies, and then the different partners in supply chain can see different information. So OPC-UI connector is able to retrieve the data from the IS and to verify which partner of the supply chain is allowed to use which data. And after the verification of usage policies, the selected data can be shown to the partner in supply chain. And this architecture has been already implemented. This slide shows our demo scenario. We decided to use table sort. This is our bulk sorter. We use it for sorting coffee beans. We model the whole supply chain in Smart Factory Web. So we model the products, country of origin, size of beans, colors of beans, and we model all customer and suppliers. For example, a customer is selling high quality beans and can make an order. The table sort has already OPC UA server, but we have extended this OPC UA server to be IIS conform. And now you can see a part of this IIS model, which covered the key aspects which are relevant for our demo scenario. And we have also defined several usage policies, how to share the process data, the product data and production data between the partners in supply chain. And then different customers or clients can see different information. For example, some customers do not accept small size of beans, and they want to know what are capabilities of table sort. There are other customers we would like to know current status, amount of already sorted beans, or we can also provide support for the suppliers. For example, someone who is producing valves for table sort to know the current status of the equipment in the production line. And this is our application scenario, and now we are going to explain step by step how this has been realized. So I gave the introduction in our system, and now my colleague Tim Watson will explain Smart Factory Web, focusing on supply chain in Smart Factory Web. Kim, please.
Yes, good afternoon, everybody. Kim Watson speaking. I'm the leader of the Smart Factory Web testbed project. The overall vision of our project is to establish a marketplace for manufacturing services, whereby factories offering manufacturing capabilities can register those and can be discovered by other factories or users looking for manufacturing facilities. This can only be possible for small lot sizes if there's a flexible adaptation of production. And of course, the motivation is to enable new business models, especially for small and medium-sized enterprises. Next slide, please, Ljiljana. In this short presentation today, short overview, I want to mention mainly aspects about the supply chains. Of course, in today's global world, you need not just individual factories, but production in entire supply chains. This makes the overall coordination, of course, more challenging. Increases, on the other hand, the opportunities for manufacturing as a service. And in the next slide, Ljiljana, I'll show you a little bit about that. In our work on the Smart Factory Web, we have looked at a number of different supply chains. The one shown here on the left is a real supply chain of the company Naga IT that makes fair trade computer mouses, and the one on the right hand side is a fair trade chocolate supply chain. The key messages here are that we need to increase the transparency of information in the supply chains and control the transparency of the information to meet fair trade principles. And the other key message in the bottom right hand corner is that we need, especially in today's world of pandemics, we need to deal with risk management along the supply chain to be able to cope with interruptions in the supply chain. Next slide, please. And the Smart Factory Web as a project has turned into a type of ecosystem, and here we show it between three very important initiatives. The IDSA initiative, that's the focus of this seminar today, and then the bottom right-hand corner, the Industrial Internet Consortium, one of the leading organizations in the area of industrial Internet of Things, and not just for manufacturing applications. And at the top, very well known, the Plattform Industrie 4.0, that is, of course, in the manufacturing sector, quite important. These organizations are linked to each other. There's a formal liaison between IDSA and the Industrial Internet Consortium. There's a cooperation agreement between IDSA and Platform Industrie 4.0, and there are a number of joint working groups and projects to promote the technologies and to advance them further, because there are still gaps in the overall standardization, especially at the semantic level. So this was a very quick overview of what the Smart Factory Web is doing in the supply chain sector. There is a video that we have prepared that will be put on our website fairly soon, along with accompanying reports. Thank you.